Hey, this is Mark, and we are going to be solving some quadratic equations. More specifically, we are going to define a function to find the values of x that satisfy the conditional quadratic equation expressed in the form ax squared plus bx plus c is equal to 0, such that x is going to be a real valued number. Now, to get started defining our function, we are going to use def. So we have a function being defined here, and we're going to give it the name quadsolve. And this function is going to have three arguments, a, b, and c, which happen to be the parameters of our equation. Now, the first thing we're going to find is the value of the discriminant. So I'm going to assign the value of the discriminant to the variable disk, and the discriminant is b squared minus 4ac. And for now, I'm just going to return the value of the discriminant to make sure our function is working. And we're going to need some test equations. So let's go ahead and just list a couple equations that we know the number of solutions and the nature of those solutions. So we have a couple equations here with two real solutions, one with one real solution, and one with no real solution. So let's go ahead and test our function. In the first case here, where we expect no real solution, the value of the discriminant should be negative, and our function works. Let's try one real solution. The value of the discriminant should be 0, so we put in those parameters, we get 0. Now for two real solutions, the value of the discriminant should be positive, so we'll try a couple of these. One is positive, so two real solutions. Let's try one more. 2, -11, and 5, and this will return a value of 81. So it looks as though our quadsolve is doing a good job at finding the value of the discriminant, which tells us the number of solutions and the nature of those solutions. So whether they're real or not real. So now let's break these into cases. The first case is going to be when the value of the discriminant is less than 0, and we'd expect no real solutions in this case. So if the value of the discriminant is strictly less than 0, we are going to output some value. Now the second case is when we have one real solution. So that will occur when the value of the discriminant is equal to 0. So we're going to use elif here. So elif, the value of the discriminant is equal to 0. And then the last case is two real solutions. And this is the only ones that remain. So this is just going to be an else statement. So if the value of the discriminant is less than 0, right now we are just going to output a print statement, and the print statement is going to have the string no real solutions. Now if the value of the discriminant is equal to 0, we have one real solution, so we are going to print one real solution. And well, what's left? Two real solutions. So we would output the print statement, two real solutions. Now we're going to have to change the value of the return from disk to output. So let's give it a try. So once again, we're still really just looking at the value of the discriminant, and we can see here two real solutions. In this case here, we should expect no real solutions. It works. So this is starting to work out. Now, we don't need to do anything for the first case when it's less than 0. We're still going to print no real solution. But if it's equal to 0, I actually want to print out that solution as solution 1. And in the curly braces is the value solution 1, and this is called an f string. So it's going, when it prints out this string, it's going to replace solution 1 with the value of -b over to a. So let's give this a try. So do we have a one real solution equation? Yep. So let's change the parameters to -4, 12, and -9 as the arguments of our function. One real solution, x is equal to, what was that, 1.5? So let's go ahead and now let's fix up this two real solutions 1. So we're going to let x equal to solution 1 and x is equal to solution 2. And we're just going to go ahead and define solution 1 and solution 2. So solution 1 is going to be x is equal to -b plus the square root. Okay, so we need a square root function here. Let me just close some of this code up here to make it a little bit easier to read. And let's insert, we'll import this one from math. So from the math library, we're going to import the s square root function. So we're going to take the square root of b squared minus, we've already calculated the value of the discriminant. So why don't we just use that variable? So we're going to take the principal square root of the discriminant, and then we are going to take this numerator and divide it by 2a. And solution 2 is going to be negative b minus the principal square root of the discriminant over 2a. And watch what happens when I run this. So we're going to go back down, and we want one with two real solutions. So let's try this. We'll use the case where we have 1, 7, and 12. Well, we get two real solutions, but it hasn't given us the solutions. We must write that string as an F string because we are asking for the values of solution 1 and solution 2 to be substituted. So we have an F string now, and now we will actually see the values of those two real numbered solutions. Now, let's go ahead and try a couple others here that are two real valued solutions. I'm going to try the one with 2, negative 11, and 5. And that also works, so we get two real solutions and it's able to find those. But watch what happens when I try this one, where we have 3, negative 11, and 5. We get these large decimal expansions here. So we are going to round the value of these solutions. And I'm going to round them to 3 decimal places to the right of the decimal place. And this is a built-in function to Python, and we will see now when we run this, we will get two solutions that have 3 decimal places to the right of the decimal. So it looks like we've got a pretty good function here that's able to solve quadratic equations. Of course, you could do a lot more with this, but I think this is a good starting point.